Okay, hey guys, so the plan for today is to look at logical equivalences in maths and logic. So it's going to be quite a short one. There's just a few rules that I'd like to go over, and then if there's any questions at the end, you can feel free to ask them or throughout the session. Okay, so we're going to start with De Morgan's law. Can anyone tell me in chat, what does De Morgan's law state? Flip everything, I like that. Okay, so it tells us if we have A and B, this is the exact same as not A or not B, all knotted. So A and B is the same as not A or not B. Yeah, perfect, Hooks. And so if we, this would probably be a better way to write it. Okay, yeah, and then the same with or. So not A or B is the same as not A and not B. So De Morgan's law provides these two equivalences, and it's quite useful to know about them and know where we could use them. Yeah, okay. And then a quick implication elimination. If we know that we can get from A to B somehow, and we can get from B to A, then we can gather that A implies B and B implies A. Therefore, A is true if and only if B is true, and B is true if and only if A is true. Yeah, so you might see this sometimes. It's just good to keep mindful of that. Okay. So we're going to start with conjunctive normal form. Conjunctive normal form is a way in which we can write our Boolean expressions. And the definition is it's ands of ors of literals, where a literal is just an atom or a negation of an atom. So whenever I'm talking about an atom or a negation of an atom, that might be something like A, or it might be something like not C. These are just literals. And so each or of literals is a clause. So let's say we had some clauses, and this could just be A or B, maybe not B or C or D. And even just not C on its own. Even though this is just a literal, it would still be an or of literals, just with 0 ors. And so this would also be a clause on its own. And so with these three clauses, what we can do is we can put them together, connect them by ands. So something like this, where we have A or B, not B or C or D, and not C. And so these are all connected by ands. And so this would be an example of conjunctive normal form. This is just a Boolean expression written in conjunctive normal form, because each of these is a clause, and each of these is just an and of those clauses put together. Okay, and so on the other hand, disjunctive normal form is the inverse. So let's say we had some clauses like each clause is an and of literals this time. So A and B, maybe C and not D. And so disjunctive normal form is just all of these clauses of ands connected by ors. So in this case we might have A and B or C and not D. And so this here is an example of a clause, and this is our or. This is our disjunction. And so that's disjunctive normal form. Yeah. See someone's typing, so give it a second. Let me know if there's any questions about those two. The NF is named after the outer operator. Yeah, so the NF is named after whatever's outside these clauses, what connects the clauses together. So this is a disjunction, which is or, and then and is a conjunction, which is, yeah. Cool. Okay, so with DNFs are very easy to see if it's, to check for satisfiability. So what makes a formula satisfiable? Let's just recap. What does satisfiability mean? Yeah, good. So there's just some valuation, which is some truth assignment for these Boolean values or these atoms, which lead to this whole thing being true. So we can easily check for that in disjunctive normal form, because we can just check each clause individually. We can say A and B, okay, A is true, B is true. Therefore, this makes it satisfiable. Because in DNF, only one of the clauses need to be true for the whole thing to be true, because it's just a disjunction, because it's just all of them ORed together. So we can check each clause and just derive a valuation based on that. Say, for example, at the end of this we had something like or A and not A and B. Say we were checking this clause, we'd come across A, we'd set that to true, we'd come across not A, and we'd see that as a conflict, and so we'd go to the next clause to see if that's true. And we keep doing that until we've gone through all the clauses and we check if it's true or false. And so that's how we can easily check for satisfiability on a DNF. Okay, so that's DNF decidability, not decidability. That's DNF checking for satisfiability. But the SAT problem is talking about CNF specifically. And what the SAT problem tells us is that we have no known polynomial time algorithm which we can use to check if a CNF formula is satisfiable. I mean, one way we could do it is through brute force, but this would be in exponential time. Simply because 2 to the n is just calculating how many possibilities there are. So if there's two variables, a and b, we could have 0, 0, 0, 1, 1, 0, 1, 1. So here there's 4 possibilities, 4 possible truth assignments. And because there's two variables, that's just 2 to the 2. But when we have something like 1,000 variables, that's going to lead to math error on my calculator. But that's going to be an insane amount of valuations. And there's no known way to check in polynomial time relative to n whether a CNF is satisfiable or not. One approach that has been sort of researched is the Davis-Putman Loveland algorithm. This isn't in polynomial time, so this again is still not in P, unfortunately. So, but what this algorithm says is we first consider our easy cases, where if an atom P only appears as either P or not P inside a clause, we just assign the truth value accordingly. And then we branch, we choose another variable and we set a truth value to it. And then if one clause is true, we compare it with all the other clauses. And we keep running this until all the clauses have been removed, in which case all of them are true, and so it's satisfiable. Or one clause is empty, which means one is false. And so from there we can work backwards. You can almost imagine it as like a recursive tree where we constantly try different truth assignments until we reach a SAT one. But again, this ends up trying everything, which in the worst case, this will try every possible truth assignment, which would just be exponential. So I thought let's finish by just tracing through that. So A or B, and not A or C, and A or B or C. So if we wanted to follow DPLL to see if this is satisfiable, does anyone want to have a go? Or what would be our first step? Okay, let me copy this and put it in the... I'll put this in the chat actually. Try setting A to true. Okay, so if we give A, let's do this in yellow. Okay, let's say A equals true. So this would then be, so you set A to true. So now this becomes true or B, and so we know not A would be false, and true or B or C. Okay. So as soon as we've done that, we can get rid of. So we can get rid of all of the clauses where there's a true. Now we know that A's in here, so we can get rid of this clause. I'll cross it out actually. We can get rid of that. We know there's a true in here, so we can get rid of that. And then we're left with this clause here. So the only other thing we kind of need to assign to here is the C. So if we assign C as true, then we have false or true, and all of these will be true. And so we can cancel that clause out. And because none of the clauses remain, all of the clauses have been removed, this would then be marked as satisfiable. Cool, as Ash said, A is true, C is true, and B, because we've not defined B as anything, whether B is true or false, this will still be satisfiable if A and C are both true. Okay, let's try it with an unsatisfiable one. Okay, so A or B, and not A or B, and I believe that's unsatisfiable. Okay, let's see. So again, what should we start with? First thing we want to do is we want to give, let's say atom A, because it appears as A. Let's say A is true. Okay, so now we have true or B, and false or B, and not B. So again, we can get rid of this. We know that's true. True or B is just, false or B, sorry, is the same as just B. False or anything is just anything. And then not B, we don't know yet. So now we're left with B and not B. So let's try setting B to true. Then we're left with B. So no, then we're left with true and false. We can't do that. So in DPLL we'd backtrack and we'd go to B equals false, and we'd say, I'll do it like that. B is false. Then we'd get false and true. And because we've reached the end, and at this point we'd see one of the clauses is just empty, and so one of them would be false. We'd have to see that it's not possible to backtrack, and so this is unsatisfiable. Yeah. Okay. And then that's DPLL. Are there any questions about that algorithm? Or is that all good? The idea is just we sort of keep applying different truth values, but we do it in a more systematic way, which makes it slightly more efficient than brute force in most cases. Would you not backtrack and set A to false? I believe, let me see. So backtrapping, there's a different truth value for. I think you would. Is a clause being empty? Yeah, so what happens is when we get the negation of an atom, we essentially just get rid of that, because it's the same as it just being false or nothing. Yeah. But I think you're right. I think we would backtrack back to this A. So as soon as we actually reach this empty clause, then we'd go back and say, okay, let's try A is false. And this would be something like false or B, which is just the same as B. I'll just not write the falses. And true or B and not B. True or B is just true, so we can ignore that. And then again we'd reach this sort of trivial condition where we have B equals, let's say we set it to true, then we're left with true and false. And we can ignore this clause, but because we're left with one empty clause, or one clause which just has false in it, it's unsatisfiable. Cool, okay. The last thing I wanted to do was just a few questions about whether these expressions are in CNF or DNF. Okay, first one. Is it in CNF? And is it in DNF? That's okay. So we've got a DNF in chat. Disjunctive normal form. DNF is if they're connected by disjunctions, so like that. That's DNF. Neither, because it could be I mean, that's a valid point, to be fair. Yeah, I guess if we're thinking about the actual precedents in which this is evaluated, it would be neither. Okay, I'm gonna change these questions up a bit. Okay, I'm gonna change that to that. Okay, so that first one, DNF. Okay. Would it also be a CNF or not? No, don't believe it would. Okay. And yeah, I'm guessing this would be evaluated like that, right? By default. And in the same way, A or B and C would be evaluated like that. Just because the and is stickier. But these brackets should just make it a bit clearer. Yeah. Okay, so yeah, this is a DNF. What about this one? DNF. Is it a DNF though? Because we've got A or B or C. So is this a clause? Yeah. So because these brackets are here, this wouldn't actually, because every clause in a DNF has to be ands. Whereas, okay, CNF, let's see. So a CNF would mean this is one clause, which would work, but because we've got these brackets again, this wouldn't be a valid clause. But if we got rid of the brackets, what would it be? DNF, yeah, it would be a DNF. And it would also be a CNF, because it's just a single clause. And so it's a CNF with one clause, and it's a DNF with 3 clauses. A or well, a CNF is just where they're joined by and. So yeah, we could say it's A and that, I think. Well, it's just A and true. Because true is like the identity. So we have to consider brackets even if it doesn't make a difference. Well, if it's changing the format of a clause, then I think you'd have to consider the brackets. But if it's, in this case, where it's just a single clause, you can almost imply the brackets. But this and this would be passed differently because the brackets enforce the order in which you do it, in which you evaluate it. Yeah. Okay, so this is a CNF and a DNF. What about this? What about just P on its own? Both, again. Good, okay. And how many clauses of each? It's just... yeah, good. A single clause in a CNF or a single clause in a DNF. And what about this final one? DNF. Yeah, good. So, I believe these two are identical actually. Yeah, okay. Perfect. Yeah, so that's the difference between CNFs and DNFs. One is a conjunction of disjunctions of atoms, and one is a disjunction of conjunction of atoms. I'll post these slides as well in #recaps. Are there any questions about anything we've covered today? Anything anyone's unsure about? I'll just give a scroll through the slides. De Morgan's law. Then we have this proof. CNFs, where it's an and of ors of atoms. DNF, or of and of atoms. DNFs are easily checked for satisfiability, where we can just use this as a truth assignment, and then use this as a truth assignment, and then use this as a truth assignment until we find something that's satisfiable, or we reach the end of the clauses. CNFs can't be checked for satisfiability in polynomial time, 2 to the n would be exponential, and that would be the brute force approach where we try every possible truth valuation. DPLL is an algorithm we can use to check for CNF satisfiability. It's still not in polynomial time, but it can possibly make it more efficient by making us, it's better than 2 to the n. But one thing I'd say is, it would be slightly better than 2 to the n, but it would still be exponential, where we just sort of assign truth atoms, and you can almost imagine DPLL as working as a tree, where each node represents some sort of valuation, and so we check this valuation. If that doesn't work, we check this. If that doesn't work, we go back up. We check this. If that doesn't work, we check this. So it's almost like we're checking all of the possible valuations, but in a more systematic way. Okay. So that's DPLL, and then we checked whether it was satisfiable or unsatisfiable for these two expressions. And then finally, seeing if these are in CNF or DNF. Remembering a single atom on its own would be both a CNF and a DNF. This would also be a CNF and a DNF. It just depends on how you interpret it. Yeah. Okay, are there any questions? If not, I hope that was useful, guys. If you do have any questions later on, just drop them in general and I'll try and answer. But otherwise, take care, guys.